Good morning, guys. Good morning, am I audible?
Yes, sir.
Yes, sir.
Okay. So, have you found the module? Have you found the dynamic load and the wear load? Everyone? Yes. How much is the module for this particular thing? All of you find the module. 4, okay. Have you checked for the design stress after taking it as 4? So whether it is less than the design stress, whatever the value.
Yes.
Okay, good. So should I solve it once again here onto the class, or after that shall I continue? Should I solve it here or shall I continue after the module calculation? Is everyone comfortable with the module calculation?
Yes, sir.
Okay. Okay. So what is module that you have decided upon after standardizing? 4, isn't it? Okay, that's great. And what is the sigma D2 value that you have got? It should be less than 137.34 megapascal. How much is the value? 133, yeah. Okay. 133.4 megapascal. So I guess the factor of safety would be very, very less. See, 137 is the allowable stress value. Okay, but you are applying how much? You are applying 133. Only there is 5 megapascal difference. That's it to the maximum. Okay. No issue. We shall just check this out. Okay, this is the conclusion. So we have decided upon the module number 4. Very good. Next, what do you have to do once this is done? You have to check on the dynamic load, isn't it? So next, we should check upon the dynamic load. And this particular dynamic load is given by FD, and expression to calculate FD, you can take it from the data handbook. It says FD plus K3V into CB plus FT whole divided by K3V plus square root of CB plus FT. From this, the value of K3 is taken from the data handbook. It is 20.67. C value, for our goodness, he has given directly, I guess. What is the value? It is 522.464 Newton per mm. Okay, just substitute. I guess you have to calculate FT for this. FT you already calculated, I guess, right? So how much is the value of FT you have got? 14.2 kilonewtons. Okay, just substitute all the value and give me the value of FD. FD is 14.2. Okay. So what is FT value then for module number F? .11. Okay. Now, wait. How did you calculate the value of FT? How did you calculate the value of FT? How did you calculate? Whether you have used 2mt divided by d? Please interact me with guys. This is very important. Whether you have used this particular formula to calculate FT. Kiran, ನನ್ನ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೆ ನಾನು ಮಾಡ್ತೀನಿ ಓಕೆನಾ Okay, now while calculating FT, there is a factor known as CS, which is known as a service factor. So have you taken care of this particular factor? Have you taken care of? Have you included CS in your calculation? No, not mentioned. Very good. So let us look into it. So he has said this particular sentence here, right? 8 to 10 hours per day, and it experiences the medium shocks, he says. That is nothing but he has given us the hint of the service conditions. So these are what? These are nothing but the service conditions. So from these service conditions, we should extract the value of CS. Got it? And for this, you have a separate designated table for this to extract the value of service factor. Can you just check your data handbook and let me know? All of you just check your data handbooks for the service factor table. If you find it, just let me know. $12.8 to 35. Yes, exactly. Very good. So here it is. So here he has given 8 to 10 hours per day, which is this type of service, and he has given the medium shocks. So what could be your service factor? So you have to pick the value from here, 1.5. So take this particular value of 1.5 here. Now you calculate your module, everyone. Now you check for the stress. So before going to all this stuff, okay. Content outside the page. What is that, Dhanush? So we have to consider, what was the table number? 12.8, right? I will just write here. So 12.8 slash 235. So after considering the service factor, what is the sigma D2 value will you get? 462.0.6. Okay, FT value. Okay, fine. So I would take that. So from this FT value, we would get as FT value is how much? 4620.6. Okay. With this particular FT value, design stress is how much? 20.34. Is that correct? The applied stress. Is sigma D2 value 200.34 is the right value after considering the service factor. Then what is the right value, Nitesh? What is the right value? 200.11, close, very close. So how many of you got this value of 200? Very good. 200.11. So most of you are getting 200.11. Now the thing's gonna change, I guess, right? So after all these calculations, what happens? Your D2 value is 200 megapascal. It is not less than 137.34. So what do you have to do? What do you have to do? Now, whatever the applied stress value we have got, it is not less than 137, which is allowable stress value. So what is the next step? Arif, Sheikh Muhammad Arif. Anurag.
Yes, sir.
So what do you have to do? Change the value of m. So again, look into the table. Standardize, take m is equals to 5. Okay. Take m is equals to 5 and solve. I'll just come back. Okay, come on, let us solve for m is equals to 5 now. We'll just grab all this. M is equals to 5 mm. Okay. So once m is equals to 5 mm is calculated, next you calculate the value of PCD of the pinion. That is D1 is equals to m into Z1. That is 5 cross 31. That is 155 mm. Similarly, PCD of care D2 is equals to m into Z2. That is equal to 5 into 100. That is equals to 500 mm. Face width B is equals to 10 times of module. So 10 into 5, that is 50 mm. Okay, so again write the sentence since CV was assumed, check for sigma D2. For that, you'll be taking this particular expression by sigma D2 cross CV cross B cross Y cross M. V is equal to pi D2 N2 divided by 60. That is equals to pi cross 0.5 cross 310 divided by 60. That is equals to 8.12 meters per second. So taking Bart's formula for velocity 8 meters per second, you have CV is equals to 4.58 divided by 4.58 plus V, that is equals to 4.58 divided by 4.58 plus 8.12. So CV value is 0.3606. Okay. So once you have got that, so calculate the value of FT. So FT is 2 times of NT divided by D cross CS. So CS has to be taken for 8 to 10 hours per day and medium shock. So from table number, so what is the table number? I have to just scroll up. Oh, already you have given sigma D2, 90. .8, page number 235. Okay, there you have depend upon this service factor as 1.5. So that I am going to use it. So that is equals to 2 cross 616.08 cross 10 to the power of 3 divided by 500 cross 1.5. So your FT value for this particular scenario would be 3696.48 Newton. Now same thing, if you substitute here, it would be 3696.48 is equals to pi cross sigma D2, that is to be calculated 0.3606 cross 50 cross 0.12 1449 cross 5. Now, your sigma D2 value would be 90 megapascal, which is lesser than 137.74 megapascal. Am I correct? Am I correct? Oh, 119 barutta. Gauss. So according to the textbook, it is 90 megapascal, the exact value. Just check. 90, yes, 90.89. Okay. So this is the procedure through which you can fix upon the module. So the important point in this particular problem, what we have learned, I have just highlighted in the red color, and I am doing it for all the problems what we have done till now. So wherever there is an important point, I am just a new thing which we have learned. So I have just written in the red color so that it would be helpful for you. Okay. FT value is 2464.32. So I have in the textbook it is mentioned as 3696.48. This is the FT value. Mithun, just check. So once you confirm, then only then we will move on. Okay. Because I don't want to be getting the wrong answers after this. Just check now. Correct. Mithun, just check and give me updated. Siddharth Shekhar. Siddharth Shekhar.
Yes, sir.
So, how much design stress value did you get?
Sir, doing sir.
Sigma D2, how much did you get? Siddharth Shekhar.
So sigma D2.
Sigma D2.
0.8, sir.
How much? How much? Siddharth Shekhar.
89.8.
How much? Siddharth Shekhar. I'm asking you fourth time. How much sigma D2 did you get?
Sir, 89.8.
Show us. Switch on your camera and show us.
Sir,
Switch on your camera and show us your problem. I know few people will be there. What was his name? Siddharth Shekhar, right? Okay. So every day I will caught hold of one such persons, and I will definitely mark their identity with good amount of colors. Okay, so that I will get an idea while I'm evaluating them for the internals, isn't it? Control F. Siddharth Shekhar. Yes, Siddharth. We are all waiting for you to show us the answer.
I don't have the it's still
Yes.
I don't have the calculations in mobile.
Calculations in mobile. I don't want all those stuff, guy. So what I'm asking you is,
Yeah,
whatever you have, forget about it. Whatever you have solved, just show us. Show me your notes. No, it's already been 8 classes. So almost we have covered 6 problems on design of gas. Show us your notes.
Yes, sir. I have some.
Hmm. Okay.
I'll call you after the.
Oh, take all your time and give us your notes. Okay. Ah. Hey, L ಇದು sigma D bantena. Sorry, FD bantena. How much is the value? 18.39. Is that correct? Value? Mithun, use your value corrected. Mithun Nayak.
Yes, sir. I got same answer. 3696.
Hmm. Okay. 18.38 FD. Correct? 18.38 kilonewton. Okay. Now, what we have discussed in the last class, guys? What we have discussed in the last class? That whatever different types of load you calculate, whether it might be endurance strength or it might be wear strength, strength in the sense it is same as the load. So either you can call it as load or you can call it as strength. Okay. So whether if you calculate endurance strength or wear strength or dynamic strength, which value should be lower when compared to all those? Which value has to be lower when compared to
FD.
So FD has to be lower, isn't it? I told you in the last class. So for that, we will compare one by one. So since he has asked us to check on, just read the question once more. So check the design for dynamic load. Have you checked the design for dynamic load, whether it is okay? We have just found out the value of dynamic load, isn't it? Yes or no, man? Hey, wait. Don't go till I say to calculate FD value. Wait. Good. But wait. Okay. Now we need to calculate the wear load and suggest the suitable harness, he says. Okay. So we have calculated the value of dynamic load, isn't it? That is the value of FD, which you have calculated. But he is asking us to check the design for dynamic load. Whether we have checked it, we have just calculated it, but not checked it, I guess, right? Am I right?
Yes, sir.
Very good. So what you have to do is, this particular dynamic load, I have to check whether it is right or wrong. Okay. Now, for that, what I have to do, I have to calculate endurance strength. What I have to do, I have to calculate what? Endurance strength. So why are you calculating this particular stuff? To check dynamic load. To check dynamic load, calculating endurance strength. Endurance strength is nothing but F to the suffix en. Just check your data handbook. If you found a formula where I can calculate FEN, just give me that.
Page number 208.
208, very good. FEN.
12.13 D.
Okay, it is 1.5 times of this thing. FD directly he has given for shock load and the data quality. So he has mentioned a medium shock, isn't it? Okay. Let us have a check. We'll take that, no issue. So FEN is how much? 1.5 times of FD. So just calculate it, and this particular thing you have taken from where? You have taken from 12.13D. So 12.13D, page number 208. Okay, you have taken it. Definitely it will be greater than FD now. It is 1.5. 1.5 times of 3, 38 and rest aito. How much did you get?
27.57.
So 27.57. If you do it, it will be definitely greater than the dynamic load. No point in doing it. It is not so feasible. Check for another any formula. Can you use this as suggested by Dhanush? Shall we use that? Okay. There is no point in proving with empirical relations. So if you prove all these relations, if you see here, see 1.25D for steady load, okay, and 1.35D for pulsating load. All these expressions are known as empirical relations. Empirical relations ಹೇಗೆ ಮಾಡ್ತಾರೆ ಅಂತಂದ್ರೆ ಈ ಅಡಿಗೆ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ 1 cup ರೈಸ್ಗೆ 2 cup ದಾಲ್. Getting my point? So 1 cup ರೈಸ್ಗೆ 2 cups of water. Those parameters are gained by experience. Okay, ಮಾಡ್ತಾ ಒಂದು parameter ಗೆ fix ಆಗಿರ್ತದೆ as a thumb rule. So those type of relations are known as empirical relations. They do not have any logical proof for that. So 1.5D ಕೊಟ್ಟಿದ್ದಾರೆ, there will be no logical proof for this. So always do not trust empirical relations. Go with the standard relations, which is this. Okay, FEN ಅದನ್ನು ತಗೊಂಡು ನೋಡೋಣ. So FEN is equal to, just give that formula. So FEN is equals to sigma EN B Y and M. So all these parameters are there. Yes. So what is sigma EN? Any information regarding sigma EN? How do I calculate sigma EN? Last problem ಅಲ್ಲಿ ಹೇಗೋ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಲ್ಲ ನಾವು. What was the table number?
12.15.
12.15. Okay. So here it is, the value of sigma EN. Okay, endurance limit for checking the beam strength of the teeth. Okay. So grey cast iron BHN. ನಮಗೆ BHN ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾನ ಅವನು? Has he given
ಇಲ್ಲ sir.
something about BHN? BHN ಕೊಟ್ಟಿಲ್ಲ. ಮತ್ತೆ ಎಂತ ಮಾಡೋದು? Okay. So we come to this particular table number, which is 12.7, where he has given the allowable stress value for us. Okay, allowable stress values in a particular. Now, whether we are designing all these things on this, we will decide upon whether we are deciding all these things, designing all these things based on gear or based on pinion, on which we are designing all these
Gear.
things.
Gear, sir.
So we are designing all these things on the gear. So what is the value of sigma D2 that he has mentioned in the problem? Allowable stress value. Allowable stress value. How much is the value that he has mentioned there? Okay, 137.4. Just check this particular value, whether you have it in the table or not. Whether you have it in the table or not. Okay. What is the material that you can pick up? Just a minute. Our cooker sound. So, this is the way you have to analyze the things. Now we have to pick the material for your thing and then choose the hardness number. So, which we are going to choose, which is close to the allowable stress value. Which material is close to the allowable stress value? 137.4, the cast steel ಅಂತ ಹೇಳಿದ್ವಿ. Okay, cast steel ಅಲ್ಲಿ ಯಾವುದು? 0.2% untreated. So shall we take this then? Is that the final decision for all of us? Or there are any other things? Any other options? ಬೇರೆ ಏನಾದರೂ ಆಪ್ಷನ್ ಇದೆನಾ? Whether you have any other options. So I guess there is a bronze option here, correct? About 138 is the design stress. But look at the Brinell hardness number. Hardness is like wear load tumba kami baratte. So always prefer a material which has a greater hardness number, so that your wear could be less. So idukku 180 go, I feel it as doubt. Mentioned in the question already. What he has mentioned? Oh, material is given in the question. Then it is inevitably he has mentioned it as cast steel. He has mentioned it as cast steel in the question.
Yes, sir.
If it is mentioned in the cast steel, there is no doubt you have to take this particular thing itself. Okay, so just take that. Brinell hardness number as 180. So just write it in your notes here while calculating sigma En, since the Brinell hardness number for gear is unknown. Since the Brinell hardness number for gear is unknown, referring material of gear from table number 12.7/234. Okay, we choose based on given data, or you can write it like this: based on given data, material for gear. Alpha Zeno. Material for gear is of cast steel. Therefore, we fix upon. Therefore, we fix upon what? What is that sentence? I mean, cast steel 0.2% untreated. Fix upon the material. Hey, yeah, alphas. Okay. Material of care as what is that material we fixed upon? Cast steel other. Steel 0.2% carbon. Cast steel 0.2% carbon. Okay, untreated with, this is important, with PHN value, how much? 180. Okay. So next. Now, for the value of 180, I need to calculate the sigma En. Now come back to that particular table. What was the table? Sigma En. Okay. Now, what was the Brinell hardness number of the game material? What we have put upon? It is 180. So just check for 180. Steel. Go for steel. Steel. Okay. See, okay. We don't have for 180 here. So what we have is, we have the value for 150 and we have the value for 200. Correct? Any other values for the steel which is nearer to 150 and 200? I have the value for, I should have the value for 180. 180 ಗೆ ಏನಾದರೂ ಕ್ಲೋಸ್ ಇದೆನಾ ಯಾವುದಾದ್ರೂ ಕ್ಯಾಸ್ಟ್ ಸ್ಟೀಲ್ ಅಲ್ಲಿ ಅಥವಾ ಸ್ಟೀಲ್ ಅಲ್ಲಿ any values is closer? $200. That is what? 150 ಮತ್ತೆ 200. So for 150, again normalization method you have to use. Normalization method ಅಂತಂದ್ರೆ I would just write it here so that it will be so BHN 150 ಇದ್ದಾಗ you would get how much? Sigma En value 259. Similarly, BHN 200 ಇದ್ದಾಗ you would get sigma En value 345. Now I require the value for 180. So how to do it? Okay, so for that you just do this particular thing. Okay, how many of you remember the method which I have explained to you in the last time while we encountered same sort of situation? Yes, here it is. Okay, I would just take all this stuff. Okay, learn this stuff. This is very important. Okay. Okay. So what I have done is I have just renamed this as Z. Okay, this as X1, this as X2, this as Y1, and this as Y2. Okay. So the value for 180 could be what? It is Y1 plus Z minus of X1 divided by X2 minus X1 into Y1 minus of Y2, or Y2 minus Y1. This is Y2 minus Y1. Just try to substitute all this. Y1 is 200 plus Z is 180 minus of X1 is 150 divided by X2 is 259 minus of X1 is 150 into Y2 is 345 minus 200. So what is the value? Understood this particular method? You have to remember this. You have to remember this formula. By this you can calculate Z. How much is the value? $239. So 239, and even I have cross-verified this method also. 239.9 idre you'll approximately take it as 240. Okay. Anyone cross-verified this particular method through which I am doing it? Because normalization of these values. Yes.
ಸರ್ ಈಗ 150 ಅಲ್ಲಿ ನಮಗೆ ಸಿಗ್ಮಾ ಇ ಅನ್ನು 259 ಉಂಟಲ್ಲ,
150 ಅಲ್ಲಿ
150 BHN ಗೆ
ಹೌದು ಕಣ, ನೀವು ಕರೆಕ್ಟ್ ನೋಡಿ.
170 ನಮ್ಗೆ ಇಷ್ಟು 180 ಬೇಕಲ್ಲ, 259 ಗಿಂತ ಜಾಸ್ತಿ ಇರಬೇಕು.
ಕರೆಕ್ಟ್ ಕಣ, ಕರೆಕ್ಟ್. ಯು ಆರ್ ರೈಟ್. ಸೊ ಇದೇನಾಗಿದೆ, ಸೊ 150ಗೆ ಎಷ್ಟು ಬಂದಿತ್ತಲ್ಲ ವ್ಯಾಲ್ಯೂ? 150ಗೆ ಎಷ್ಟು ಬಂದಿತ್ತಲ್ಲ ವ್ಯಾಲ್ಯೂ? 259 ಇದೆ, ಕರೆಕ್ಟಾ? ಸೊ 259. ಸೊ BHN X ಅಂತ ತಗೋಬೇಕು, ಎಂಡ್ಯೂರೆನ್ಸ್ ಲಿಮಿಟ್ ಅಥವಾ ಎಂಡ್ಯೂರೆನ್ಸ್ ಸ್ಟ್ರೆಂತ್ Y ಅಂತ ತಗೊಳ್ಳೋಣ. ನೌ ಇಟ್ ಮೇಕ್ಸ್ ಸೆನ್ಸ್. ಸೊ 150ಗೆ 259 ಆದ್ರೆ 345 ಯಾವುದು? 200ಗೆ 245. ಸೊ ಸೆಂಟರ್ ಅಲ್ಲಿರೋದು 180. ದಟ್ ಐ ವುಡ್ ಟೇಕ್ ಇಟ್ ಆಸ್ Z. Okay. Now it makes sense. Now if you substitute it, just check now. Y1, it is 259 plus Z. Z is 180 minus X1 is to 150 divided by X2 is 200 minus 150 cross 345 minus 259. ಈಗ ಎಷ್ಟು ಬಂತು?
ಸರ್ ಅದ್ಯಾಕೆ 259?
y1 ಅಲ್ಲ, 150ಗೆ 259 ಉಂಟಲ್ಲ, ಕರೆಕ್ಟ್ ಅಲ್ಲ? 150ಗೆ 259 ಅಲ್ಲ, 150 BHN ಇದ್ರೆ 259 ಸಿಗ್ಮಾ ಎನ್ ಬಂದಿರೋದು. 150 ಇದ್ರೆ 259 ಸಿಗ್ಮಾ ಎನ್. 200ಗೆ 345 ಬರುತ್ತೆ. ಸೊ 180ಗೆ ಎಷ್ಟು ಬರುತ್ತೆ ಎಂಬುದು ನನ್ನ ಕ್ವೆಶ್ಚನ್ ಇವಾಗ. Very good. Now it makes sense, right? Exactly. Very good. ಯಾರ ಪಾಯಿಂಟ್ ಹೇಳಿದ್ ನನಗೆ? Nitish. Okay. Very good. Very good, Nitish. Now it makes sense. Okay. Even I have verified this particular formula. I have tried on another aspects as well, and it gave the right result. So you can blindly trust this particular formula, what we have used and what we have framed in our last class. Okay. So when to use this formula? ಯಾವಾಗ ಯೂಸ್ ಮಾಡೋದು ಇದನ್ನು? When to use it? Anyone? Alphas.
Yes, sir.
So when to use this particular concept? ಯಾವಾಗ ಯೂಸ್ ಮಾಡೋದು ಇದನ್ನು?
Hello.
When to use this particular concept, man?
Sir, can't hear, sir. Network is breaking, sir.
ಹೋಗ್ಲಿ. ಇನ್ಯಾರಿದ್ದಾರೆ? ಗಗನ್ ಹೇಳಿದ ತಕ್ಷಣ ಹೊರಟೋದ. ಗಿರೀಶ್. ಗಿರೀಶ್. ಹಶೀಲ್. ಗಿರೀಶ್ ಅಂಡ್ ಹಶೀಲ್ ಇಬ್ರು ಇಲ್ವಾ?
ಎಸ್ ಸರ್.
ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು? ಇದನ್ನು when we have to use it. Radvik.
ಎಸ್ ಸರ್.
ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನು?
ಚೆಕ್ ಮಾಡುವಾಗ. ಎಂಡ್ರೆನ್ಸ್ ಲಿಮಿಟ್, ಇದು ಡೈನಾಮಿಕ್ ಲೋಡಿಂಗ್.
ಅಲ್ಲ ಕಣ, ನನ್ನ ಕ್ವೆಶ್ಚನ್ ಏನು ಅಂತಂದ್ರೆ, ನಾವ್ ಇಷ್ಟೆಲ್ಲ ಸರ್ಕಸ್ ಮಾಡಿದ್ದೇನಕ್ಕೆ? ಆಲ್ ದಿಸ್ ಸರ್ಕಸ್ ಅಂಡ್ ಕಟಿಂಗ್.
ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂ ಹುಡುಕ್ಲಿಕ್ಕೆ
180ಗೆ ಎಕ್ಸಾಕ್ಟ್ ವ್ಯಾಲ್ಯೂ ಹುಡುಕ್ಲಿಕ್ಕೆ. ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಇಲ್ಲ ಇದು. Everyone got this or not? So when you don't have the value for middle one, suppose if you refer the data handbook, clearly see here, for 150 you have a value which is 259. Next, for 200 you have a value which is 345. But I need the value for 180. Ellide 180 ille illa. You cannot approximate here. Okay, that is when you have to use this particular formula here. So for 150, 259 is the parameter. For 200, 335 is the parameter. Okay. Similarly, for 180 ಗೆ ಎಷ್ಟು parameter ಅಂತ ಕಂಡುಹಿಡಿಯಲಿಕ್ಕೆ this particular formula you have to use. You have to take it as x1. This you have to take it as x2. This as y1 and y2, and use this formula y1 plus z minus x1 divided by x2 minus x1 into y2 minus y1. Use ಮಾಡಿದ್ರೆ you will get the approximated value or the exact value for 180. ಅರ್ಥ ಆಯ್ತಾ? Got it?
Yes, sir.
Okay. Table number, what was the table number through which you have get? It is 12.15, page number 238. 12.15, page number 238. Now all of you just calculate FEN. Now since sigma En is calculated, it is easy to calculate cross P, cross Y, cross M. Every value is known. Just substitute the value and calculate. Sigma En you have fixed upon 310.6 cross. B value is 50 cross. Y value is what? It is capital Y is just 5 times the small y. Okay, so it is 0.1449 cross M is again 5. So what is FEN? Fast, it's already time. 35.0. Very good. I'll just take it as 35 kilonewtons. Okay. Now, what was our dynamic load? Dynamic load is Tito. What was our dynamic load?
18.38.
18.38. Whether this is less greater than the dynamic load, now even the dynamic load is less, isn't it? So I can write FEN is greater than the dynamic load. Therefore, the material, since FEN is greater than dynamic load, I can write it as the material is safe against static load. Okay, just write this sentence and end up. And even you have to check for the wear load. We will do it tomorrow. Some of you have already calculated the wear load. We will do it tomorrow once again. Okay. Now only for the endurance load we have checked upon for the dynamic load now. Okay. Okay, guys. So just it's already been late. So mark your attendance in the attendance sheet within next few minutes, and you can leave the class. We'll meet up in the tomorrow's class. Okay. Till then, take care. Have a nice time ahead.